Hi there, this video covers section 1.3 on evaluating compositions of functions. So what is a composition of function? What do we mean by that? Well, we're talking about evaluating functions not at numbers, but at letters, numbers, or even other symbols, or even functions themselves. So let me show you some examples to clarify what we mean by composition of functions. And then, of course, let me also show you the answers of how we compute those things. So example A here, we have f parentheses x plus 3. This is pronounced f of x plus 3. Be careful not to confuse this with multiplication. It reuses the parentheses, but not to mean multiplication. It means evaluating at the point or when the input is x plus 3. And mathematics does not color code. It uses letter coding. So the F refers to the F equation, which is right over here. So we would know to use x plus 3 as the input into the F equation. Well, the F equation is negative x squared plus 8. We know x is the input because it says f of x. So the x is where you put stuff in. Instead of putting in 5, we're putting in x plus 3. So we literally put in x plus 3 right here. So that's what f of x plus 3 is equal to. It's the negative of x plus 3 squared plus 8 because the original rule was negative x squared plus 8. I do need to simplify this because we do need to simplify our answers. So I'll square out x plus 3 squared. If you want to do some side work to do x plus 3 squared, remember square means times itself. There's no such thing as a distributive property with squaring or any exponents or square roots or anything like that. You do have to multiply it out or FOIL it out or whatever method you learned in computing binomials multiplied out. So this is x squared plus 3x plus 3x plus 9. And so this ends up being x squared plus 6x plus 9 once you combine the two 3x's together. And lastly, I'm going to distribute the minus sign, minus x squared minus 6x minus 9 plus 8, and then write the simplified answer as negative x squared minus 6x minus 1. The minus 1 came from combining together the two constant terms, negative 9 and positive 8. All right, so there's an example of calculating f of x plus 3. Well, in example B, we have f parentheses g parentheses x parentheses parentheses. It's getting a little more complicated. So what's going on here? Well, it's really kind of the same problem as we saw before. It's f of a thing. We're taking this thing that's inside the parentheses of f of x plus 3. We just did that before. F of anything, we plug that thing into our equation. So what's our equation? Well, our equation is negative x squared plus 8. That's the f equation right here, negative x squared plus 8. What are we plugging in for x? We're plugging in g of x. Now, it didn't look like we did much, but g of x can be written according to this rule as negative x, excuse me, as x minus 2. So instead of writing gx here, I'm going to write x minus 2. So that's f of the gx function. The gx function is x minus 2, so it's f evaluated when the input is x minus 2. And in a very similar way, we'll need to simplify this to write our answer. So you can check the work for this one. When I square x minus 2, I get x squared minus 4x plus 4. Don't forget that I have a plus 8 at the end. And then I get negative x squared plus 4x. I have a minus 4 and a plus 8, which ends up being positive 4. All right, if you haven't done already, if you haven't done so already, this is a great time to pause this video and try the rest of these problems. See if you can find g of f of x or g of x squared or any of these other problems. Great time to practice those. All right, hopefully you had a chance to do that. Welcome back, and I'm going to write out the solutions for the rest of these problems. All right, well, I'm going to have to make things a little bit smaller because I need to see my equations. So g of f of x, the g function is x minus 2. So this is equal to x minus 2. And what is x in this case? It's fx. So I'm going to have an fx there, but as you may know, I'm not going to use the symbology fx. I'm going to simplify it, writing what the fx is. So the fx is negative x squared plus 8. So it's the thing x minus 2, the thing being negative x squared plus 8. There's nothing to square out this time. I'm just going to be able to combine like terms. So negative x squared, I have a plus 8 and a minus 2. That results in a plus 6. And you may notice that when I put the gx inside f of g of x, I get a very different answer than I do g of f of x, because you're putting different things into different functions. All right, next up is example D, where I'm doing g of x squared. That means I take the g function once again. The g function is x minus 2, or thing minus 2, and I put my x squared in there. There's not much to do here except for remove some parentheses, and that's my answer for g of x squared. For example E, it looks very similar. It says g of x squared, but you may notice that the square is not inside the parentheses. I'm not putting x squared into the function. I'm squaring what g of x is. So g of x is thing minus 2, but the thing inside the parentheses is still x. So it's still x minus 2. That didn't change because inside the parentheses, I'm substituting x for the input, which is still x. But I am now squaring. Make sure you use parentheses so that you know the entire gx is being squared. And then I would have to write this out and go ahead and square it. I'm not showing my steps on squaring out this, but you can write out the x minus 2, and FOIL it to check that you do get x squared minus 4x plus 4. All right, a couple more problems. We have fx plus g of x squared. So fx, that rule is up here. Remember, fx is up there. Fx is negative equals negative x squared plus 8. And g of x squared, well, there's a plus, and then g of x squared, well, we just did that one. That was the x minus 2 squared thing, right? That was literally the same answer from part E. So as long as we combine these things together, we will have the answer to expression F. I'm just going to copy over my answer from before. So it's plus x squared minus 4x plus 4. I do need to combine like terms together. There's two constant terms, and there's also two x squared terms. And I'll just combine those together. I have a negative x squared and a positive x squared. Those give me 0. I have an 8 and a 4, which is 12. And we have a minus 4x. So that's your answer right there. Some people were taught in a previous math situation that you're supposed to write the x thing first. So if you're in that mindset, you certainly can write negative 4x plus 12 instead of 12 minus 4x. It's really up to you. It doesn't matter. All right. Now we have h of x plus a. So I have to learn what the h function is. The h function is square root 8 minus x. Maybe I'll just write that over here. just so I don't have to keep scrolling up and back to remind myself what the hx is. So for letter G, we have h of x plus 2. According to the rule, h of x is square root of the x thing. Excuse, the good thing I wrote it right. 8 minus the x thing. So h of anything is 8 minus that thing, all under a square root. So what is the thing that we're plugging in? Well, if you're thinking x plus a, you are absolutely correct. And then we can simplify this a little bit. We distribute the minus sign. There is no distributive property with squares or square roots or anything. The only thing we ever have distributive property for is multiplication or division with the parentheses and things added or subtracted together. So this is as final we can get in terms of our answer. All right, and then we got one last problem here, h of f of x. So we know what the h function is. I wrote it right here. H of f of x is the square root of 8 minus thing. Of course, our thing is fx, but we're not going to put an fx in there. We're going to actually simplify because we know what fx is. Just to remind you, if you want, fx is negative x squared plus 8. So we're going to put negative x squared plus 8 in there. And this square root should go all the way across. There we go. And I have to simplify this thing. Well, I will distribute because it's multiplying -1 times the parentheses of things added together. So this is 8 minus 1 times minus x squared is positive x squared. And -1 times positive 8 is -8. There are two constant terms, and they combine together to equal 0. Some people say they cancel. I'm a little bit wary of using that word because it kind of hides what's going on, and I see a lot of mistakes that people make incorrectly canceling things. So what's truthfully happening is we have an 8 and we have a -8. They add to 0. Anything plus 0 is just 0. So we have square root of x squared, and the square root of x squared, if you don't remember from your pre-calculus class, is equal to the absolute value of x. Right? Some people think it's equal to x, but it's actually equal to plus or minus x. Just to make sure that you remember that as well. All right, so in this video, I tried to describe what the composition of functions is, and we did a bunch of examples of simplifying compositions of functions. Hopefully this video was helpful to you. Please reach out if you have any questions or need help with any of these types of problems. All right, great. I hope you have a nice afternoon.